So now that we've talked a little bit about what these imaginary and complex numbers are, we need to take a look at how do we go ahead and add, subtract, multiply, or divide them. And so we're going to look at a couple of examples, and I think you'll find that it's very similar to when we added, subtracted, multiplied with those binomials, right, with our polynomials. And so what you're going to do is you're going to put the real parts together, put the imaginary parts together, and then write your final answer in a specific form. So for example, in this part A here that you see, the first thing that we're going to do is find our real parts of each of those. And since we're adding, we don't need to worry about changing any signs or anything like that, but we're going to put those real parts together. So 4 plus a negative 11 is negative 7. That was our step 1, right? Combine our real parts. Step 2 then says we're going to take these parts that are imaginary with that I on it, and we're going to put those together. So a negative 7i plus 9i is going to give us 2i. Okay, really what I should have done is I should have written that down on this next line here. So this will be 2i. Those are my imaginary parts put together. And my final step is to make sure that I write it in that a plus bi form. We always want our real number first plus our imaginary part. And so then that is our final answer. Okay, part B then says find the difference. So now instead of adding them together, we're going to subtract them. And so we're going to start like we did last time, looking at those real parts. So 6 minus 2 is 4. And 8i minus a negative I. Be really careful about those signs, right? 8 minus 8i. Well, let me rewrite that. 8i minus a negative 5i, right? We need to be careful about those subtractions. Remember, any two subtraction signs together or negative signs change into a positive. So 8 minus a negative 5 really becomes 8 plus 5. So we're going to then have 13i. We want to make sure that it's in that form, a plus bi. So here's our final answer. Okay, let's look at one more example here. Negative 4 plus a negative 2 is a negative 6. 6i plus a negative 9i is negative 3i. Always make sure it's in a plus bi form. There is our final answer. Now, when we multiply these, we're going to do it just like we did with binomials, right? Where we're distributing. You could use the box method, use whatever method that you used before. This I is really just kind of doing the same thing as any of our variables would be. So we have an I kind of at the end. All right, so I'm going to distribute. For this one, I want to make sure that I distribute it onto both parts, right? So 2.5 times 8 is 20. Leave that I in there. Minus 2.5 times 9. Negative 22.5. This is going to be an I squared. Now be really careful. Anytime we see this, we know that an I is the square root of negative 1. Right? I squared. If I square that square root of negative 1, I squared is really the same as negative 1. All right, so we should never see anything bigger than an I in this spot because it's this. We can simplify it. remember there's a little note right here on your notes as well that I squared is the same as -1. So instead of having negative 22.5 I squared, this really is like saying negative 22.5 times -1, which in fact is positive 22.5. Now remember, our final answer always should be in A plus BI form, so make sure you rearrange that. Okay, let's multiply this next one. I'm going to do a box method for this one. So I have a 3 and a negative 2i, a 3 and a 2i. Okay, so as I take those numbers out of the box, I'll get 9 plus 6i minus 6i minus 4i squared. Plus 6i and minus 6i are going to cancel each other out. Remember that I squared is really the same as a -1. So this is going to turn into 9 plus 4, which is 13. Okay, so if you see these i's adding, subtracting, multiplying, it's really going to look the same as when we did those with the binomial. What those i's mean are really going to be the biggest difference that you'll see, but your strategies that you're using are going to be the same as when you used a binomial.